In this video, we're going to create a bare metal application that will access a large SRAM in the PolarFire SoC FPGA fabric using a fabric interface connection. As we mentioned in the introduction video, you need to have a copy of the latest Icicle Kit reference design from GitHub. If you need to generate a copy of the design, watch our video called Getting Back to Factory Defaults. The link for that is available in the description below. When you've generated a design, the Auto Layout feature in the Smart Design canvas can make components easier to see. If we zoom in, there's a large SRAM connected to an AXI4 interconnect. The interconnect is connected to FIX 0 of the PolarFire SoC MSS. The large SRAM is connected to Slave 1 of the interconnect. You can double-click on the interconnect to open its configurator. When it opens, click on the Slave Configuration tab. Slave 1 is configured to have a start address of 61 million hex and an end address of 6 and all Fs hex. If we open up Soft Console, we've created a project based on the MPFS MMUART interrupt project, as all of the build settings are already configured. In the U54_1, we've released MMUART1, FIX 0, and the FPGA fabric from Reset. We've also enabled the system clocks. We've configured UART1 and created a pointer here with an address of 61 million hex, matching the address of the fabric SRAM connected to FIX 0. Initially, we write 32 words of incrementing data to the SRAM, then read it back and verify that the data read matches what was written to that location. If the read doesn't match, we've set a breakpoint on line 133, which we will reach if a data read is incorrect. Otherwise, we'll get UART prints saying that the read was verified and giving the expected and read data. We'll build the project so we can test it in debug mode. Once that's complete, we can start up a debug session. We have COM14 open, which is connected to MMUART1. Now that we've reached the U54_1 main, we're going to select Resume, and all the data writes and reads begin. We can see the program has completed and all of the reads have been verified with the expected data and the data read from the FPGA. Now that we have verified the application, we can build it as a payload for the HSS. To do this, open up the MSS software config file. It's found in the source folder, in Platform Config Reference, and then the MPFS HAL config folder. In here, there is a define for MPFS HAL hardware config. To build our application as a payload loaded by the HSS, we need to undefine this line, as this hardware configuration will have already been completed by the HSS. And we can now build this application to be used as an HSS payload.